Very good morning, my dear students. How are you? How is going on your studies? Okay. Today I will give one important concept, that is the graphs. So today I will explain A to Z about the graphs. That graphs is not only useful in physics, it is useful in maths and chemistry also. If you see last year question papers and before last year question papers, definitely you will get at least 2 or 3 graphs on that question papers. So that's why today I will give detailed information based on the graphs. No need to search any textbook, any material. So just I will give you one very important concept, complete information about the graphs. Okay. See here. Now comes to graph. Graphs. Okay. So for example, if anybody asks y equal to mx plus c, y equal to mx plus c. So how to draw the graph based on y equal to mx plus c? So see here, I take y-axis and x-axis. This is the y-axis, this is the x-axis. Next, here if you see here, C is the intersecting point on y-axis. So m is the slope. So the slope makes an angle about the x-axis. So that means you will get graph like this. Here this point we called intersecting point about the y-axis. Next here slope theta. So angle of tangent is represent slope m equal to tan theta. So here slope, if anybody asks slope, simply calculate angle of tangent, that is nothing but slope. Next, if you draw the graph on x-axis and y-axis, this slope, once you see here, I will take x-axis and y-axis. So here, this is the nature of the graph. So if you observe this nature of the graph, see here, simply I take one small point and draw the graph about the tangent like this. See here, this is the, if anybody asks question like this only, what is the slope? So simply I take x here and I take y here, and you take any one point on this graph. Okay, see here, I take one point here and draw the tangent like this. This angle of tangent theta. So here, this is the slope. The slope represents simply y2 minus y1 by x2 minus x1. So simply I will represent here delta y by delta x. So delta y by delta x is represents slope. Okay. Next, if you observe some more graphs, sometimes they are asking question area. How to calculate area? So here I take one graph, x-axis and y-axis. X-axis and y-axis. So here somebody they given graph like this only. Now how to calculate area? So simply I take one small strip like here. Next. So this area under this curve represents area. Under this curve represents area. So this is the y, this is the small dx. So area integration y dx. Integration y dx. So integration y dx is represents area of this curve. Next, if you observe very carefully, if any graph if I take one graph on x-axis and y-axis, if y is constant, that graph nature is represents like this. Y is constant, that graph is represents like this. Next, if anybody asks, x is constant, here x, here y. So x is constant, you will get nature of the graph like this. This is the parallel to y-axis. If y is constant, parallel to x-axis. Okay, here x is constant. Next, somebody asked question, so if x is equal to y, how to draw the graph? X is equal to y, how to draw the graph? So that means here x is equal to y. So nature of the graph is represents like this. So this is the x, this is the y. This is the minus x, this is the minus y. The nature of the graph is represents like this only. So if anybody asks question, y is equal to x square. Y equal to x square. If anybody asks question, definitely you will get only first coordinate. So here this is the x, this is the y. This is the nature of the graph is represents like this only. Nature of the graph is represents like this. So this is the y equal to x square. Next, if anybody asks question, y is equal to x cube graph. Are you ready to solve this problem? So how to draw the graph? Y equal to x cube. Okay. So if you observe here, y equal to x cube graph. See here. This is the x, this is the y. So the nature of the graph is represents like a tan graph. So for example, if you take x is equal to 1, so at the same time y equal to 1, x is equal to 2, y equal to 8. Here also you will get x is equal to minus 1, minus 8, minus. So here you will get like that only. So graph, nature of the graph is represents like this only. Next, see here, if anybody asks y is equal to ax minus bx square graph. So very important graph. So here nature of the graph is represents parabolic path like this only. Parabola. Nature of the graph is parabola. So at the same time, if anybody asks question, y is equal to ax cube plus bx square plus here, for example, if you see ax square plus bx plus c, what is the nature of the graph? If anybody asks like this only, so you will get parabolic path but like this only. So this is the nature of the graph. Okay. Next, you observe very carefully. Simply I am telling basic concepts and basic principles. Next, if anybody asks here y is equal to e power x, y is equal to e power x curve. So here if you see here, y is equal to e power x curve is represents like this only. So y and x. So y equal to e power x curve represents like this only. Now y is equal to e power minus x curve. If you see y equal to e power x curve, that curve is represents like this only. So here it is moving like this and here it moves like this. Simply both in opposite direction. Next, if you see y is equal to ln x, y is equal to ln x. Sometimes we call y is equal to log x. log x graph. So log x graph is represents like this only. So on x-axis and y-axis. So this is the nature of the graph ln x. Okay. Next. Now very important graphs. Y is equal to sin x. Y equal to sin x. See here. How to draw y equal to sin x here? For example, x is equal to 0. I take x on x here, y here. Next, x value x is equal to 0 and you will get start here. X equal to 91. So that means the nature of the graph is represents like this only. Next, y equal to cos x. Brother, sister. So here simply observe here, this is the cos 0, value is x is equal to 0. At the same time, so cos value, cos x is equal, cos 0 equal to 1. So that means it is started here like this one. This is the nature of the graph. Brother completed, sister completed. Next, what about wife? So if you see here, this wife is very danger. So that means simply observe y is equal to tan x. So x-axis and y-axis here, the nature of the graph is represents like this one. Like this one. Okay. These three graphs is important based on the sine function, cos function, tan function. Next. Okay. Next, very important. XT curves. XT curve. A graph drawn between displacement on y-axis and time on x-axis. Time on x-axis. And the slope is represents. The slope is represents velocity. Very important. A graph drawn between displacement on y-axis and time on x-axis. The slope is represents. So here slope is represents velocity. That velocity is instantaneous velocity. What type of velocity that one? Instantaneous velocity. So that means if you see here, that value m is equal to tan theta equal to slope value. If you observe here, if I draw like this, this is the s, this is the t. So that means if you see here, change in displacement delta s, change in time delta t. So this is the instantaneous velocity. Instantaneous velocity delta s by delta t. Okay. Slope I calculated. What about area? Area. So a graph drawn between displacement on y-axis, time on x-axis. What about area? So area is simply here, this is the x dx sometimes. Otherwise y dy. Otherwise if you take any integration s here, this is the t, this is also t. Okay. So this is also t here. So this is the displacement time. Displacement time. Area integration x dt or integration s dt. The product of displacement and time. What the meaning? No meaning. So this is the meaningless. If anybody asks what is the area between the displacement and the time, you say meaningless question. Understand? Why? Because of, so here a graph drawn between displacement and time, slope is represents velocity, but area meaningless. Okay. Next. Now comes velocity and time curve. Velocity and time curve. So here a graph drawn between velocity on y-axis, time on x-axis. Velocity on y-axis, time on x-axis. So here the slope, if you draw the slope, this is the slope. The slope is represents acceleration, that is instantaneous acceleration. Instantaneous acceleration. So that value simply delta V by delta T. Next, very important, see here, this is the acceleration. If anybody asks question, what about area? Area. So a graph drawn between velocity on y-axis, time on x-axis, that area so simply represents here integration V dt. This value represents displacement. Displacement. A graph drawn between velocity on y-axis, time on x-axis. So at the same time, the area under the curve represents, this is the area. This area represents displacement. Next, if you observe here, acceleration and time curve. Acceleration and time curve. So if I draw the acceleration on y-axis and time on x-axis, the slope is represents a by t. A by t. So or simply delta a by delta t. So we called jerk. Jerk, not in syllabus. Simply the rate of change of acceleration we called jerk. Next, if you draw the graph between the area, between the acceleration and time, this area is represents a dt is represents simply velocity. You remember a graph drawn between velocity, acceleration on y-axis, time on x-axis, the area under the curve represents velocity. Okay, next. Now we discuss some applications based on the graphs. Okay, see here, for example, I take displacement on y-axis, time on x-axis. So here, this is the graph. Now they are asking question about this graph, what about velocity and what about velocity increases or decreases, and they are asking accelerations. So here you simply remember, very important, keep in your mind. So simply if anybody asks about velocity or some areas like that only, so at that some time you take one point here, is it right, and draw the tangent about that point. So that value, that means that angle is less than 90 degrees, that velocity is positive. Theta is less than 90 degrees. Velocity, instantaneous velocity is positive. Okay. Next, they are asking question, what about that velocity? Increasing velocity or decreasing velocity? See here. Next, I will draw one more graph here and take the graph like this. And you choose any 2 or 3 points about that graph like this. Now, this is the point A, this is the point B, this is the point C. Here I take time and this is the displacement. Draw the tangent like this. This is the theta 1. Next, you take one more graph like this. This is the theta 2. Next, if you draw one more graph, this is the theta 3. So if you observe that theta value slowly decreases. If theta value slowly decreases, that means velocity also decreases. Okay, so that means here theta 1 is greater than, theta 2 is greater than theta 3. At the same time, in this graph, velocity also slowly decreases. So what we call, so this type of velocities we call decreasing function. So here decreasing velocity. So if you observe, velocity is positive, this value decreases. So that type of accelerations we called negative acceleration. Because of this negative acceleration, this velocity gradually decreases. Okay, I will give one more example based on this graphs like this only. See here. I take one more graph like this. This is the displacement, this is the time. If anybody asks question about this graph, so this type of graph, once you see, they are asking what is the velocity, and this velocity increasing or decreasing, what about acceleration. So simply you take one point, at anywhere you take one point and draw the graph like this. Draw the tangent. So if you draw the tangent, that value, theta value less than 90 degrees. So this type of graphs we called positive velocity. Next, what about that velocity? Increasing velocity or decreasing velocity? So simply I will take one more graph like this only. So here I will take one point here, another point here, another point here. I draw one tangent here, I draw one more tangent here, I will draw one more tangent here. So if you observe very carefully, this theta 1, theta 2, theta 3, that value theta 1 less than theta 2 less than theta 3. So this means when angle of tangent increases, velocity also increases. When velocity increases, so here positive velocity increases, that means positive acceleration. Okay, this is the basic information about the graphs. Okay, I will give one shortcut trick. Some innocent students so simply asked me, sir, how to remember this much of graphs? Okay, I will tell one shortcut trick. So here a graph drawn between displacement on y-axis, time on x-axis. So if you get smiley symbol, this is the smiley symbol. That smiley symbol represents positive acceleration. Anywhere you will get this type of nature of the graph, that is the smiley graph. Smile means positive. Next, if you get anywhere, so this is the displacement time graph. If anywhere you get sad graph, sad symbol, that sad symbol represents negative acceleration. Smiley, positive acceleration, sad symbol, negative acceleration. Okay, so just you remember, anywhere if you get this type of graphs, positive, negative. Okay, next, see here. Now you tell, what about this graph? Okay, what about this graph? So here I will take displacement on x-axis and negative velocity on y-axis. This is the velocity, negative velocity. So it moves like this. So in this situation, what you observe? So if you observe very carefully, if you draw here, this value, this velocity is increases. This velocity is increases. But in which direction? Negative direction. Negative value increases. Next. So what about here, this graph here? If you increases like this, you will get smile. That means velocity and acceleration both are same direction. So this type of graph, simply you remember. See here, in this situation, this is the smile graph. That is means positive. Downward direction, acceleration and velocity both are same direction. This type of graphs. Okay. Next. Once you observe, small example. So for example, this is the like this. Origin, a graph start from origin. This is the displacement time graph. 0, 10 meter. This is also 10 meter. 15 meter. This is the 15 meter. This is the 20 meter. Now they are asking question, what is the velocity from O to A to B and B to C? Okay, very simple. So simply remember, a graph drawn between displacement and time, the slope is represents velocity. So that means VAB slope. So what is the higher value here? 10. Lower value, if you observe here, lower value is 0. Next, in this situation, here seconds, this is the second, this is the second, this is the second. Okay, so here highest time is 10 seconds and lowest is 0. So that means 10 by 10, that equal, you will get 1 meter per second. In this situation, what is the velocity here? 1 meter per second. So in this situation, velocity is constant. What about acceleration? Acceleration is 0. Why? Because of when velocity is constant, so acceleration is 0. Next, if you observe here, between only A and this is the BC. In this situation, slope, angle of tangent is 0. That means acceleration. That means velocity is 0. And if you observe between A and B, acceleration, if velocity is 0, acceleration 0. Why? Because of it maintained constant. Next, if you see one more application here, BC, velocity BC. What about slope here? The slope higher value is 15 and lower value is 10. Next here, if you observe here, 20 minus 15. If you subtract this value, BC is equal to, so 5 by 5, that equal to 1 meter per second. What about acceleration? So here it is moving with constant velocity, no change in slope. Very, very important. Here also no change in slope. Here also no change in slope. That means BC equal to 0. Okay, just you remember and apply the concept. In this concept you should be apply in examinations. Okay. See here, previous JEE examination. So one body is projected vertically upward with velocity 10 meter per second. With velocity 10 meter per second. It reaches maximum height. After that, it strikes on the ground. Again, it make multiple rebounds like this. Now they are asking question, what is the nature of the graph? What the nature of the graph? See here, in this situation, first, when ball is projected from the ground, what about time of flight? So that means first I will calculate here time of ascent. Why I am calculate time of ascent here? After what time this velocity becomes 0? After what time this velocity becomes 0? So if you see time of ascent equal to u by g. So time of ascent is equal to this value 10, this value 10. So 10 cancel. After 1 second, final velocity is 0. After 1 second, this final velocity is 0. After what time it reaches the ground? That is called time of flight. So t equal to 2u by g. Time of flight formula, t equal to 2u by g. 2 into this velocity is 10, g value 10, this one cancel, 2 seconds. 2 seconds. After 2 seconds, it reaches the ground. Okay. See here how to draw the velocity and time graph. Velocity and time graph. Now see here. What about initial velocity? 10 meter per second. Velocity increases or decreases here? Velocity decreases. Finally, it comes to 0 at highest point. What about time here? It take 1 second. After that, what happened? It changes direction, comes to negative x-axis. So negative direction like this. So after what time it reaches the ground? After 2 seconds, it reaches the ground. Okay. Next, it rebounds. At t equal 2 seconds, it rebounds. Again, it continue the same path like this. If I draw, you will get like this. So this is the nature of the graph. So same like this only. Okay. Next, one more problem. Okay. One more problem. See here. This is the one tall building of height h. A person drop this stone or ball with velocity u equal to 0. When it is reaches the ground, after that what happens? Strikes on the floor, again rebounds and reaches the height h by 2. Now draw the graph. They are asking question like that only. A ball is dropped from the height h. When it strikes on the ground, some energy loses. It rises maximum height h by 2. Now draw the graph. Okay. See here. This is the very important model. See here. This is the velocity time graph. So initially this is here I will take here velocity on y-axis. This is the velocity and distance graph. Velocity and distance graph. Okay. So how to draw this type of questions? See here, initially velocity is 0. Initial velocity is 0. Okay, 0. After that what happened? It moving downward direction, its velocity increases along with acceleration. So that means you will get like this. This is the negative acceleration. When it is strikes on the ground, after that what happened? Its velocity direction changes. It has some value like this. So if you observe here, when it reaches the highest point here, h by 2 distance, velocity again it comes to 0. So this is the h distance, this is the h by 2. So this is the nature of the graph. What about acceleration? In this situation, you got smiley. That smiley represents positive acceleration. Next, in this situation, you got the sad symbol. This is the negative acceleration. negative acceleration. Why? Because of simply in this situation velocity and acceleration both are same direction. Velocity increases. In this direction velocity is moving upward direction, acceleration is downward direction, velocity is decreases. So you will get this type of graphs. Okay, next one more problem. Last problem. Next, see here. A ball is projected from the ground. Finally, it reaches the ground like this. Now they are asking question how to draw the graph. A ball is projected with initial velocity u. So it moves under the influence of gravity. Finally, it reaches the same point. Now they are asking question, what is the nature of the graph? Like this. So here, initially it has velocity. That velocity gradually decreases. Time on x-axis, velocity on y-axis. Here it has velocity like this. For example, this velocity value is, I will take 10 meter per second. 10 meter per second. Okay. Now you see here, again it reaches highest point, velocity is 0. After that, direction changes, again it travels like this. Finally, it reaches the ground, the same velocity, same magnitude, but in opposite direction. Now they are asking question, what is the displacement? Okay. See here, what is displacement means? So in this situation, at what time velocity is 0? That means the time of ascent equal to u by g. So time of ascent equal to u value simply 10, g value 10. This one cancel. 1 second. After 1 second, this velocity is 0. Next, time of flight t equal to 2u by g, that equal to 2 into 10 by 10. This one cancel. 2 seconds. So after 2 seconds, this velocity is reaches here. Okay. So now they are asking question displacement. A graph drawn between velocity and time. This area, this is the area S1 and this area S2. This area S2. Okay. So if you observe very carefully, this is the more than 90 degrees, theta is greater than 90 degrees, that is the negative velocity. Is it right? What type of velocity here? Negative velocity. Okay. See here. Next, if you see this area S1 is equal to half into base 1 into height. Height how much value is given? 10. So 2 ones, 2 5s. So S1 area is represents 5 meter. Next, what about this area? So S2 is equal to, so here this is the velocity initial at the point of projection and at the reach the same point, both are has same speed. Both are has same speed but in opposite direction. So 1 by 2 into, so what about speed here? 10. What about this? This is the gap here 1. So this is the 5. So that means S2 is equal to minus 5. This is the negative slope. This value is simply very, very important. One is the positive, other one is the negative. So finally, so S is equal to S1 plus S2. So S is equal to 5 minus 5. This displacement is 0. What about distance? What about distance? Distance is a scalar quantity. If you added this area plus this area, you will get distance. S is equal to S1 plus S2. So S is equal to 5 plus 5. So S is equal to 10 meter. This is the distance. Okay. Thank you, my dear students. I hope you are enjoying the class today. So next topic is very, very important. and the topic is related to, so here a body is projected from the top of the tower. Okay, the topic is based on the JEE mains and advanced along with NEET orientation also. Thank you, my dear students. Once again, thank you. Good night.